So this new unit is going to be about parametric functions. If you turn to page 1, we're going to talk through an example about where parametric functions are useful and why we would need a third variable. So a parametric equation has 3 variables, but we'll get there. So the top of page 1, when a function is represented parametrically, 2 variables are defined in the terms of a third. It's called the parameter. If a function relating 2 variables is desired, we can eliminate the parameter to go back to a regular equation where it's just x and y like we're used to. So here's an example. For every degree above 70, a convenience store sells X bottles of sunscreen and X squared pints of ice cream. So we could write an equation that says ice cream equals sunscreen squared. But it's kind of misleading because does the input of sunscreen really affect the output of ice cream or vice versa? We have no information there about the temperature being above 70. So it's better if we include input of temperature to get output of sunscreen and input of temperature to get output of ice cream. So just having 2 variables, but it says at the bottom, of ice cream and sunscreen in this first example here, it's not really helpful. But as soon as we introduce the input of temperature, that affects the sunscreen and the ice cream. We use T for the parameter, and most often it's time. So let's turn to page 2, and we'll see our first set of parametric equations. So a parametric equation, you have the input of T, and you have the output of X and the output of Y in this case because we've given X and Y. So this is output, and this is output. So there's 2 different resulting variables for the input of T. In this situation, the problem says use T between -2 and 2. So we're going to put those values in our table, and then we have to input those to every T to get the output values of X and Y. Your calculator will do this for you. So turn on your calculator, and we have to change the mode. So press the mode button. And now instead of function here in the middle, we're going to arrow to the right and highlight parametric. Depending on your calculator, it might just say para, P-A-R-A. And then while we're on this mode screen, I want to point out something. This input variable, the x, t, theta, n, that changes based on what mode your calculator's in. So in function mode, this button gives you the x. In parametric mode, that function's going to give us the t. Polar, it would give us the theta, and sequence mode, it would give us the n. So we're still going to use this input button, but now that we're in parametric mode, it's going to create a t in the calculator. So I quit out of this mode screen and then hit y equals in the top left, and let me clear out what's there. And you'll see now that every equation comes in a pair xy, x1, y1, x2, y2, and so on. So in the x1, we're going to write 3t squared. So remember, use the input variable up here. And then the y, we've got 2t. All right, so if we use the table, it will give us the outputs of x and y. So I'm going to do second graph. Oh, mine has weird numbers in it. Okay, so first I have to fix mine. So I'm going to go second window to table set. And I'm going to arrow down and change independent to auto. So now we go second table, and I've got all these t values, and I can arrow up to negatives and arrow down to positives. And let's see, we want to start at -2. So that gives me an output of 12 for x and -4 for y. And then at -1, we've got an output of 3 for x and -2 for y. right, so keep going, copy down those numbers. And now we're going to graph. So when we go to graph, we're going to plot the points. But this graph is only two variables. We've got an X. Whoa. I was ready for my points. We got an X scale and a Y scale. I don't know why mine's. Why is that? Okay. So we got to somehow include the information about T. So I will explain how we're going to do that. 12, -4, it's going to be a little bit off your graph here. So we're going to go 12, -4, and then 3, -2, 0, 0, 3, 2, and then 12, 4. And we're going to connect the dots. And because we're only looking at these input values, we don't put an arrow past our starting point. It's more like a segment than a line. We're going to keep our graph just contained to those T values. And then I'm going to show with arrows how the movement of the graph went given the input of T's. So we started down here at 12, -4 and moved up to the point 3, -2. And then that moved to 0, 0, and then. So that's one option for showing the movement of your graph based on the input of T. Another option, it's not my favorite, is to label the T value at each dot. I think that's more work and more writing, but that's an option if you like to label the T's with the T equals instead of these arrows in between each piece. Okay, so for eliminating the parameter, that means eliminate the T. So I'm just going to rewrite both equations over here. And we are going to use either substitution or elimination. And in this case, because we have a T squared, substitution will be easier. It's easiest to isolate T in the Y equation. So I want everyone in the Y equation to do some PEMDAS backwards so that it's T equals. We're solving for T. And now we can replace the T in the X equation with Y over 2. So we've got X equals 3 times Y over 2 squared. We can make that look a little nicer. We can square the Y, square the denominator, and then that gives us 3/4 Y squared as a final equation. All right, let's try number 2. Our input variable is T, output of X, output of Y. The T's are between -2 and +2. Okay, now we got to go to our calculator. So I'm going to go to Y equals, clear out what's there. Let's see, X is 4T. Y is T squared plus 1. Second graph. Copy your numbers into your packet. Let's put the points on our graph. -8. All right, connect the dots. Okay, don't go past these endpoints because our inputs are limited to just between -2 and 2. We do need direction arrows to show which way that input of t impacted the graph. All right, and now for eliminating our parameter, it's easiest to isolate the t in our x equation. I'm going to start there by dividing by 4. And then we can replace the t in the y equation with x over 4. I'm going to square that fraction. It's quadratic. All right, we've got x squared. And we can see with transformations, just to connect this to what we've done before, the graph has moved up 1. So the vertex is up 1. And this coefficient of 1/16 is making it very wide. It's that vertical shrink where it's vertically pushed down. So it's a much wider parabola because of that 1/16, that vertical dilation. All right, let's try page 3. Input of t, x and y. This time our t's go from -1 to 4. Y equals, clear out our equation. Write down the points. Uh-oh. Oh, wait, I made a mistake. That's better. All right, so we've got 3, -10. 4, -6. Okay, when you connect the points, don't go past those endpoints. And we have to show the direction. Whoa. This time we've got a linear equation. It's a straight line. It's not shaped like a parabola. So I like to use combination or the elimination method when I have a linear equation. This is actually going to help us in our next unit as well. So I like to preview, or actually it's a review of this algebra way back in Algebra 1. We talked about systems of equations. So let's review how we eliminate the t. I want to be able to add or subtract these equations together and eliminate t. Right now, if I add, I get 5t, or if I subtract, I get 3t. So that's not going to work. But if I take my x equation and multiply by 4, actually I'm going to do -4 to every single term. Now, when I go to add my equations together, so I'm going to do the red and the black. When I add them, I get y minus 4x equals, the t's eliminate, and then this is -22. We like our linear equations to be y equals, so I could just go one extra step by adding 4x to the right-hand side. This is linear. So it's nice to see we've got a y-intercept of -2, a slope of 4, like you'd go up 4 over 1, the rise over run. It's okay. Like this is an okay answer. Y minus 4x equals -22. That's correct. That's a linear equation. Just a more preferred form is y equals, but both of those would be fine. All right, let's try one more. Oh, well, that's gonna be off our graph. That's okay. All right, once you get off the grid over here, just kind of estimate it. It's good enough. Show your direction. Okay, so now for eliminating the parameter, I have a 3t and a -2t, and I want them to add together to be 0. So what's the least common multiple for 3 and 2? Oh, 6. So if I make my top equation times 2 and my bottom equation times 3, remember you have to multiply every single term. Now I'm going to add them together. 2x plus 3y equals 13. Okay, so this is the general form of a linear equation or standard form. You've got x and y on one side, the constant on the other. We can leave it. It's fine. It's a linear equation again. You can see that with your graph or just the fact that there's no exponents on the x or the y. Okay, so now your practice is the next page, and we will keep going with more parametric knowledge tomorrow.